Okay, let's go ahead and get started. So, welcome everyone to our long range weather outlook, where we will review all of the interesting things going on in the weather that we could possibly review in about 25 minutes uh, right now. And so, we will be looking into this winter and then the following spring. And very excited to have our fellow stratospheric expert here, Dr. Aiden. So here he is. Aiden is an earth scientist and data engineer, expert on the stratosphere. He lives and breathes the stratosphere. And so, because there's a lot going on in the stratosphere, I thought that this would be a great time to have his expertise on the call. And introducing myself, I'm Dr. Hansi Singh. I'm CEO and co-founder of Planette AI. I'm an Earth system scientist. I used to be a fellow at the US Department of Energy, and I used to be a professor before I started Planette. And Planette in particular is our way of trying to get the best findings from the research world in terms of Earth system predictability into the real world to help folks make decisions, from market decisions to operational decisions to risk decisions. So, welcome, and it is great to have you here. So, to begin, I want to say something about the long range weather outlook and how we do it. How do we forecast weather beyond your 10 or 14-day weather app on your phone? So when it comes to long range weather, instead of using atmosphere models, which is what we do for 14-day weather, we use much more complex models. These are called Earth system models. And so the atmosphere forgets where it started from in approximately 2 weeks. Hence, your weather app on your phone only has about 2 weeks of predictability max before everything that it's going to be predicting is basically going to be climatology. In order to predict beyond that, we really need these other components of the Earth system besides the atmosphere. So this includes the ocean, this includes ice, this includes land surfaces. And these are much more complex models. And this is really a very sort of different form of science than conventional meteorology. And so it's not magic, it's science. And so we can't tell you, for example, on December 25th, am I going to get snow at my space that I'm in? We can't tell you that right now, not yet. But what we can tell you is what is the likelihood that December will see colder than usual conditions and wetter than usual conditions that are conducive to snow at your location. So this kind of forecasting is powerful, but it's really important to say that, we don't get day-to-day predictability when we start looking beyond the 14-day time horizon. Okay, so what we're going to talk about today is, first of all, we're going to talk about modes of variability, specifically QBO, ENSO, NAO, and MJO. I'm going to hand it over to Dr. Aiden, who will tell us all about early polar vortex disruptions that are on the horizon, because the stratosphere is doing some really interesting things, and I think all of us care about it. Then we'll talk a bit about the MJO, and then we'll take a look at the seasonal outlook, specifically the North Pacific Blob, a persistent NAO that's just really kind of stubbornly sort of sitting in the forecast. And so I think it's important to point out, and it has some significant implications for the longer term outlook. And then we will even make some sort of wild guesses in terms of where El Nino or La Nina are heading into the summer of 2026. So let's get started. We promised you a volatile winter. So this is a screenshot of our first ever webinar on September 17th. And we promised you at that time, hey, the fundamentals are really all set for a very wild ride this winter. And if you want to check out this webinar, this earlier webinar, as well as other webinars, the following week's webinar, for example, we went over cold snaps, specifically cold snaps that are driven by the stratosphere. And you can check out these and more on our YouTube channel, QR code here, or I think you can probably just go to YouTube and look up Planette AI and enjoy all of those exciting webinars. So let's look at the modes of variability. Modes of variability are essentially the predictable signals that we use for long-range forecasting. There are a few of them that we're going to highlight today. First of all, there's our stratospheric signal, which is the QBO. The QBO is the quasi-biennial oscillation. It is in a negative phase, and it's going to be in a negative phase definitely over the next 6 months. And this has a huge impact on the fundamentals of what this winter and the coming spring are going to look like. Then we'll take a bit of a look at ENSO, or the El Nino slash La Nina index, which is, I mean, I still want to call it neutral, though it is possibly at this point a mild La Nina. It's kind of hard to say. We have to average it for 3 months, and over 3 months, it has to exceed a particular threshold to be called a La Nina. And I don't actually think that it is officially has met those guidelines yet, but maybe it's a mild La Nina. We think that it's going to be sort of in this very sort of, near neutral state for the next few months. And then, yeah, there might be some really interesting changes that come up in late spring and summer. So we'll talk about those. Then we'll talk about the NAO. The NAO is sitting here. This is a North Atlantic oscillation. It's sitting in generally a positive phase, but in the near term, as we get these different cold snaps that's come down from the stratosphere, it will do a lot of wobbling. So when the cold snaps come down, it usually sort of moves into its negative phase, and then it'll pop back into its positive phase. But in general, the long-term outlook for the NAO is positive, and so that has some major impacts, including some impacts on how we see spring emerging over the globe. And then finally, we will also get into the MJO, which is being pretty extreme and pretty exciting. So at this stage, I am going to hand over the mic to our stratospheric expert, Dr. Aiden, who will tell us all about the show that the stratosphere has started to give us.
Yes, a show is the right way to describe it. So thanks so much, Dr. Singh. So today, what I want to be discussing with you guys is the stratospheric polar vortex. So the polar vortex is something that you may have actually heard of, but it's kind of misunderstood colloquially. We kind of use that name polar vortex to refer to a lot of things which really aren't exactly what scientifically we're talking about when we're talking about this polar vortex. So typically we talk about this vortex as existing in the stratosphere. So that's a region 20 to 50 kilometers above the Earth's surface. But although that's a very remote region, actually what goes on with that polar vortex can be really important, especially when we're talking about the winter time in the northern hemisphere. And changes in the state of that vortex can increase the propensity for us to actually experience extreme colds in what we refer to as cold snaps or cold air outbreaks. So there's two main ways that we think about this wintertime polar vortex. And those are kind of described in this figure on the top right over here. So on the left, what we have is a strong vortex or a stable polar vortex. In those cases, we have a lot of Arctic cold air that gets locked right around the North Pole. And that strong vortex is working to contain a lot of that very, very strong winter weather. However, sometimes we actually see that this polar vortex can be disrupted or it can undergo what's referred to as a weakening. And in these weakenings, that cold air, which used to be locked up and relegated to these very high latitudes, is then able to meander to much lower latitudes and give us these tastes of that really, really cold Arctic air. And this is actually quite important for what we're seeing right now, because actually over the next couple weeks, it looks like we're going to be getting our first tastes of some of that higher latitude air, particularly over the continental United States. So we wanted to highlight this not only because this looks like this is very interesting over the coming weeks to months, but also because we've been predicting a very, very volatile winter when it comes to the polar vortex. And the reason for that is, as Hansi was mentioning, the state of this polar vortex, whether it's strong or whether it's weak, can actually be tied to other patterns of atmospheric variability. And one of those patterns of atmospheric variability, which is actually incredibly predictable on timescales of up to a year to 2 years into the future, is referred to as the quasi Quasi-Biennial Oscillation. So that's a bit of a mouthful, and it actually is a signal of how strong winds are in the tropical stratosphere. So very, very far away from what we typically talk about as the polar vortex. But for some reasons that I won't really bore you guys with right now, those tropical winds can actually dictate a lot of the strength of what's going on in the polar vortex near the Arctic. So one of the things that we noticed here at Planette is in this bottom figure, what we're looking at is this is the quasi-biennial oscillation, or the QBO, over the past 5 years. And as we look into the winter of 2025 to 2026, what we were seeing is that this QBO is going to be very obviously negative, and that means that we have a much, much stronger chance of having this weak polar vortex event. And when we have these weak vortex events, again, that's going to mean a spilling of that cold, frigid air from the Arctic into lower latitudes, particularly over the continental United States and over Northern Europe. So just because we have the preconditioning of the background of what's going on with this QBO doesn't mean we can say exactly when we're going to have one of these spills of cold Arctic air, but it tells us that we're very likely to have that happen at least once or twice during the winter. So what we're actually seeing now in the forecast, and what's the exciting thing, is we're actually seeing the first of these events occurring in our forecast. There's pretty strong model convergence now that this event will occur. So what we're looking at is a cross section here of the stratosphere. So we're looking about 30 kilometers up, and where we have the blues in the figure on the left, this is showing, like, right over the Arctic Sea. You can kind of see this strong blues existing over Greenland, which is one of the normal places that the polar vortex likes to sit. These deep blues are actually telling us that the vortex is strong, but what we see is that right around Thanksgiving, so sometime next week, there's this flash in the pan of this strong red, which injects itself over eastern Siberia and into Alaska. And that does push the polar vortex to lower latitudes, particularly over continental Eurasia. And although you might be looking at this and being saying, like, maybe this isn't a huge impact for what's going on 30 kilometers up. Like, why do I think that this is actually going to be important for what's going on at the surface? Well, it turns out when we have these displaced vortices, so when the vortex gets pushed off of its preferred location, we actually tend to have much stronger and colder, much stronger cold anomalies persisting over the continental United States. So one of the reasons that we're curious about this is because this is probably going to lead to very, very cold temperatures in parts of the continental United States as well as Canada over the next couple of weeks. But also, this is one of the very first times that we have ever seen one of these events occurring this early in the winter season. So typically when we're talking about these polar vortex events, we're talking about things that may be occurring in late December, January, but now we're seeing this actually occurring in the last week of November. So this is quite anomalous in when we're actually observing this event. So, excuse me, I mentioned that this will actually be playing out and have some impact on the forecast over the next couple of weeks. So what we're looking at here is basically the temperature anomalies for the last week of November. Now we're looking at the second or third week of December. And what we see is that there's these persistent cold anomalies which are sitting over Canada and the northern part of the continental United States. And this is, again, this same signature that we would expect to see from the polar vortex. So we have this displaced vortex high up in the stratosphere that allows this spilling of the Arctic air to go much further south than it usually would. And that means that we're going to be having these much colder temperatures over the continental United States and Canada. So we're getting the first tastes of this just at the beginning of December. But I want to make sure that I'm not, burying the lead here when it comes to the polar vortex. Because typically when we have one of these events, those strongest anomalies, those strongest cold anomalies, don't actually happen at the same time that the vortex is undergoing its weakening, but instead actually happens for the next couple weeks afterward. So I think that this strong negative cold anomaly that we're seeing in the first week of December, that will actually be just the appetizer for the main course of the cold event that we'll see later on in December, or perhaps even into January. So beware, it looks like we're going to have a bit of, definitely a couple cold snaps over the continental United States and Canada going into this winter. So I think with that, I'm not sure if there's any more slides that we have on the stratosphere, Dr. Singh, but I'll throw it back to you then.
Yes. Great, great. So we are having a wild start to the official winter. So that is exciting. Thank you, Dr. Aiden. And just to confirm with you, so we expect potentially these kinds of cold conditions to continue into December,
Yes, exactly. So
throughout
while
December. Okay.
throughout December, and we don't really know exactly how the stratosphere and the surface climate will influence another yet, but what we know is that those anomalies which we typically see in the stratosphere can persist for many, many weeks. So if the surface climate can find itself another pattern similar to what we're seeing in the first week of December, then we're likely to get another one of these strong spillings of Arctic air into the continental United States.
So, okay, well, then this is time to talk about some implications of these cold snaps. So, first of all, of course, increased heating demand. It's also important to say that in some locations that are not used to this kind of cold weather, there can be pipeline disruptions. This particular event, it looks like it will cover parts of Louisiana and Texas, where we know that there are a lot of gas pipelines. So, this might be an area really to keep an eye on in terms of thinking about supply disruptions. We also know that certain winter crops, especially those kinds of crops that are used to mild winters, if they encounter a surprise cold snap, we often do see crop damage. This is something to also keep in mind. Um, Transportation fleets and associated supply chain be disrupted. And if there are major construction projects in regions where they are not used to this kind of cold weather, we can often see disruptions there as well, and specifically delays. Now, let's move on from the stratosphere, which is very exciting, to another extremely exciting mode of variability with the MJO, which is also giving us a real show. So we talked about the QBO being extremely important in terms of the stratosphere and stratospheric activity. The negative QBO is also important in terms of determining how strong the MJO signal is and how well that MJO signal is propagated around the world. So, in particular, the MJO is strong when the QBO is in a negative phase. And this just means that that tropical convection can go, way up in the atmosphere and sort of just create a really strong global signal that can propagate all over. And so I'm showing here the precipitation signals associated with the MJO. And specifically, right now, we're in sort of a phase 6 and a phase 7, and the MJO has just kind of been hovering in these phases, and it's projected to hover in these phases for the next 30 days or so. And so, what this means is that we are going to be seeing some pretty strong, we think, teleconnections associated with this. So some of these include drier than usual conditions over North America, parts of East Africa, and Argentina, and wetter than usual conditions, particularly in central Brazil. Let me get to those conditions in central Brazil. So many folks keep an eye on Minas Gerais, which is a major mining region in Brazil, specifically for iron ore, certain precious minerals, even lithium. And so this area, it looks like it's going to be hammered with some heavier than usual precipitation over the next couple of months. And this is specifically for December. This is very consistent with the behavior of the MJO. So I would consider this a robust signal and to keep an eye on potential mine disruptions that could happen. Then another interesting sort of effect of the MJO that we're seeing is drier than usual conditions over the southeast US, specifically in December. So this is another area to really keep an eye on. And in particular, this is also consistent with that super weak La Nina that's hanging out in the tropical Pacific. And so I think also, specifically also because the signal is pretty persistent here, dry American Southeast, I would consider this robust. And so something to keep an eye on as well in terms of implications in this area of less than usual rainfall. Now let's turn over from our subseasonal outlook driven by the MJO to a more seasonal outlook. So the seasonal outlook is going to be very impacted by ocean temperatures. Usually this outlook is going to be dominated by an El Nino or a La Nina. Right now we have this kind of rat's tail of a La Nina, very weak, hanging out in the tropical Pacific. And what is the bigger story, we think, are these really interesting kind of dual blobs that have sort of formed in the North Pacific. So we have a warm blob in the West Pacific, West Northwest Pacific, and a cold blob in the Northeast Pacific sitting in the Gulf of Alaska. And so, in terms of these types of features, what we expect and what we see in the forecasts are certain types of circulations, specifically a circulation that favors a more northward than usual jet stream in the Central Pacific, and then a bit of a deviation that then systems into the Pacific Northwest and away from California. And keep in mind, this little La Nina too also favors the same thing. So whenever we see two modes of variability where it seems that they are sort of coincident and causing a similar sort of pattern, it is time to pay attention. So what does this mean? So it means something that looks like this, which is a wet Pacific Northwest and a drier than usual California. So just today, there was a huge article in the New York Times specifically talking about how a housing price correction seemed to be playing out currently in high risk insurance markets. So a drier than usual California has the implications of potentially major wildfire season coming up. And so this once again highlights that vulnerable regions are going to see impacts from these types of uh, weather events and specifically drought and or drier than usual conditions that lend themselves to wildfire. And in particular, this is linked to some extent what we think might be the future of this region, which is longer dry seasons, more vulnerability to wildfires. So potentially, we're going to see another high risk fire season this year. Now, moving on finally to the North Atlantic Oscillation, we see what looks like a pretty canonical temperature pattern for a positive NAO. So a positive NAO is linked to a cold Canada, warmer lower 48, and generally strong stormy conditions in kind of the northern half of the US. It's also linked to a warm Scandinavia and a cold southern Europe. And this is sort of just a general kind of feature that's showing up in the forecast. So we do think that it's something to pay attention to. Keep in mind that this is the long range outlook for the NAO. In the next, days and weeks, we will see the NAO sort of bounce around a bit. And specifically, that's with cold snaps. Whenever cold snaps happen, the NAO tends to snap into a negative, and then it'll come back into a positive phase. So just keep in mind that this is the long range outlook for the NAO, the general kind of direction that it wants to sit this coming winter and the following spring. And so, one thing to really keep in mind that we see that looks quite robust in our forecasts is a drier than usual Southern and Eastern Europe. And this is very consistent with a positive NAO. And so, these are regions, once again, that are very prone to wildfires and very warm conditions in the summer. And so it's definitely something to keep in mind in terms of the vulnerability of this region this summer. Finally, let's take a look at the springtime. So our forecast suggests an early spring for many parts of the country, specifically most of the lower 48, other than the Pacific Northwest. Sorry, fellow Pacific Northwesterners. And also in Canada, it is likely going to be a later than usual spring. So keep that in mind. And in Europe, also, most of Europe looks like it's going to get an earlier than usual spring, except parts of Eastern Europe. So once again, this is kind of consistent with that general sort of long range NAO forecast. And it's also consistent with the fact that we live in a world that is warming. And so early springs are something to expect. And here we get a little bit more sort of subtlety in terms of where to expect them. And finally, the next summer. So, what is in store for the summer? So, I am now going to go off on some sort of definitely speculation, but this is, I guess you could say, educated speculation. And so, this speculation has to do with previous years where we've seen conditions similar to today. So, in 2014, we had a neutral ENSO, we had a giant blob in the Pacific Ocean, and we had a negative QBO. And that was a very wild winter. And from that wild winter, we went into pretty strong El Nino conditions. And the following year was a super El Nino. And when we say super El Nino, the standard deviations of this El Nino was over 2.5. So extremely strong El Nino. In fact, even stronger than our last super El Nino that happened in 23 and 24. So now here we are once again. There is pretty much neutral conditions in the tropical Pacific, maybe a tiny La Nina. We have this funny blob situation in the North Pacific, and we have a negative QBO again that's giving us a wild winter ride. Are we going to see an El Nino coming up? I would say that there is a good possibility that this summer we're going to get into a small El Nino, and it is possible that this will strengthen with time into something once again that looks like a super El Nino, and that will bring us once again into record-breaking global temperatures, which tends to be what happens whenever we have these major El Nino events. We tend to break records. So this is a possibility. This is totally conjecture, but looking at previous analog events, it is something that is possible. So I'm going to wrap up right now. Please keep in mind that there is no webinar next week because many of us will be celebrating Turkey Day. But the following week, we have a really exciting webinar where we will go into the MJO specifically, the MJ who, and specifically how the MJO is an extremely important predictor of subseasonal weather volatility, what it is, its features, and how we can utilize it for really getting insights into this subseasonal timescale. Thank you all so much. I appreciate you being here. And if you have any weather questions, feel free to contact me. I'm on LinkedIn. You can contact me at hansi@planette.ai. And we're always here to answer your pressing weather questions. And I am happy to take a couple of questions right now, though we pretty much are at time. Okay, I see one question. Is there a simple way to explain why ENSO matters to energy prices? Yeah, that is a great question. And so, just in general, when we think about ENSO and energy prices, ENSO El Nino tends to give us warmer than usual conditions over the globe. And so, it tends to mean that energy prices, specifically for the winter season, will go down because the demand will be lower. That is kind of generally the question. We got a question from Mariana about hail likelihood. And so, yes, absolutely. So the way that we estimate something like hail likelihood is specifically in our long range forecast, right? Because this is not like an hourly forecast or a next day forecast. The way that we do it is we look at something called convective available potential energy, which tells us the likelihood of thunderstorms. And in addition to that, we also take a look at specifically the humidity. So when we have really wet conditions and a lot of convective available potential energy, we tend to form the kind of juicy thunderstorms that give rise to large hail. So this is actually some work that we are exploring right now with some potential collaborators at Planette. Okay, Thank you all so much. Really appreciate you for being here, and you know where to find us. So ask us your weather questions whenever they come to you. All right. Thank you. Goodbye.